Hey everyone, this is the video for lesson 9.3. It's on from vertex to general form. So you've seen what the vertex form looks like. You've seen what the general form looks like. I'll refresh your memory in a second. But now you're going to learn how to go from one form to another, which is the main theme of this chapter, is being able to go through the three forms. There's still another form you haven't seen yet. All right, so the general form looks like this. It's ax squared plus bx plus c, and that's the sum of three terms. So a term means that there's only multiplication or division. So like this is a term because it's a times x squared. This is a term because it's b times x, and c is just by itself. You can have like just a constant. So a sum of terms with non-negative and integer exponents is called a polynomial. So like this right here is a polynomial because the exponents are positive, 2 and 1, and they're integers. 2 and 1 are integers, we know that. So this is a polynomial, but it actually has a more specific name. So an expression with only one term is called a monomial. An expression with two terms is called a binomial. Three terms is called a trinomial, so this is actually a trinomial. So it's a polynomial, but it's also, if you think more specific, it's a trinomial. And if you have like four or more, you just call it a polynomial. Alright, so some examples. This right here is just a monomial. It's one term. The exponent is 1, so that's a non-negative integer, so we're all set. This is a binomial, two terms. You're allowed to have a decimal or a non-integer as a coefficient. It just can't be an exponent. X squared plus 3x plus 7, that's a trinomial. And this is an example of a polynomial. It's got four terms. The exponent is 4, 3, 1, and then if you don't have an exponent, that's fine. It's just its own term. All right, so terms whose variable parts are identical. So I got 3x and 2x. Those are identical because it's just x. X and x. There's no exponents. Or there's an exponent of 1, but they have the same exponent. These are called like terms. So terms like this, 2x squared and x to the fourth, are not like terms because their variable components are different, because this one has a square and this one has a fourth. So if you have like terms, you can combine them. So we've talked about combining like terms before. So 2x plus 3x is 5x. This 2x squared plus x to the fourth, that's all you can do. You cannot combine those at all. You just leave it as 2x squared plus x to the fourth. All right, so now we're on to the meat of this section. So going from vertex to general. So a refresher, vertex is y equals a, x minus h squared plus k. You should remember this from chapter 8. We use that a lot. So like stretch, left and right, up and down. General, you just saw in the last couple slides, ax squared plus bx plus c. So to go from vertex to general, first you expand using a rectangle diagram, then you distribute and you combine like terms. So this should make no sense. You've never seen this before. So a rectangle diagram. So we start with some, okay, you take this right here, x minus h squared, and you expand it. So if you start with this, so let's say it's x plus 5. So this thing would have went to the left 5, remember, plus 5. So you make a box. I usually call it the box method, but the book uses rectangle diagram, air quotes there. So I use both just so you don't ask me in class, what's a rectangle diagram? Well, I call it the box. So you take this. So this right here, x plus 5 squared, is really x plus 5 times x plus 5 because I got two of them. So you take those and you put them on the edges here. So you have x plus 5 and x plus 5. Then you multiply. X times x goes in this box, so that's x squared. X times a positive 5 is 5x. X times another positive 5 is 5x. And then a positive 5 times a positive 5 is positive 25. Now to come out of the box, you add. So you have x squared plus 5x plus 5x plus 25. Now here you can combine like terms. The two 5x's in the middle combine to be 10x. So the rectangle diagram, this right here, is equal to this after you expand it. So the word expand is going to show up a lot. So we just expand it. All right, so now we're going to actually do an example where we go from vertex to general using the steps that I outlined in the last slide. So we're going to rewrite y equals 2x plus 3 squared minus 5 in the general form. So first you start by doing a rectangle diagram on that thing on the inside, the x plus 3 squared. So you got x plus 3, you fill in the inside, you add to get out, and then you combine like terms. So this right here is the same as this. Then you substitute it in. So before we had x plus 3 squared, but now we just said that those two are equal. So instead of having x plus 2 squared, we put in this trinomial. Then you distribute that 2 in, so 2x squared, 12x, 18. And then that minus 5 is just hanging out because it was here, so it's got to hang out. Then you can combine like terms. The only terms that are the same are 18 and 5. They have the same variable component, so 18 minus 5 is 13. So our original equation, y equals 2x plus 3 squared minus 5, and our new general form, 2x squared plus 12x plus 13, represent the same parabola. So if you were to graph these, they would create the same parabola. They would just right over each other. So if you have like a color calculator, like first it will draw like a black parabola, like with a black line, and then like a red parabola will go above it, or a blue, whatever color you have set up. So these are just written in different forms. So this is vertex, this is general, and later you're going to see, so in the next section, you're going to see the final form of writing a parabola. And it's my favorite one, so get ready. All right. So I highly recommend this row right here. 4 and 5 really practices using a rectangle diagram, and 10 really gets you ready for the test, because it's kind of a hard section on this test, and I think 10 really helps you with it. Alright, so that's it. So make sure you're taking good notes, make sure you take your Google form quiz, you mark as done, and have a good night.